Okay, welcome to lesson 5 on our hazardous earth. This is our final lesson now, and we're going to look at tsunamis today. And so the first thing I thought is go through the quiz from last week or last lesson, depending on when you did it. So the anagrams, we've got the first one here, get them in front of you if you're doing them. The first one here, hopefully you think that one is earthquake. The second one is seismic waves. Then this one is epicenter. Remember the area on the surface above where the earthquake occurs inside the crust. Then we have the friction, which is what's pulling, what the force that's acting when the plates are rubbing against each other. And then the last one we have is plate boundary, which is obviously where our earthquakes occur. So today we're going to look at tsunamis, and we're going to think about what are they, where do they happen. We're going to address some common misconceptions that people get wrong about them, and then we'll talk about why they happen as well. So find this sheet. That's the first thing I would say. So we're going to be working through that. So find that. It's in the links down below. You will see a link to it. You can access this sheet, you can print it out, or you can just fill it in on a Word document. It's free. Just click the link and you will get to it. I've shared it, so it's publicly available for everyone to access. If you haven't got the sheet or you haven't got a printer at home or whatever, you can do it on Word, or you can just read it and then write your own notes on a piece of paper if you want to write down on paper. So thinking about tsunamis then, what actually are they? What actually happened? So there's two before pictures here, and then this is what those areas look like after when the tsunami had occurred. So you can see this is the same place down here. You can see the breakwaters are the same. It's slightly off center the picture, but you can see all of these buildings have been destroyed here. There's not a lot left. The vegetation has been destroyed, so these trees have gone. You can see that the beach is affected. Look, the water's still here, so it's going to take some time for that water to flow away. And then again in this picture, if we look at the difference between the two, some of these houses are the same and they've managed to stay standing, but then you can also see lots of other buildings, debris, cars, kind of just general dirt and muck from the sea has come in here. The other buildings have been pushed against these ones, so they've been pushed all the way in from probably near the coast, and they've been pushed in. You can imagine there's going to be lots and lots of damage here and lots and lots of loss of life and injuries to people as well. So what actually is a tsunami? So can you write this definition on your sheet or write this on your notes? A large wave in the ocean, usually caused by an undersea earthquake or landslide. A tsunami can travel hundreds of miles over the open sea and cause extensive damage when it encounters land. So what I would like you to do is write that down. We're going to focus today on tsunamis caused by earthquakes, most of all, because they're the more common ones and ones you will have heard of previously. What's really important to know is that tsunami waves do not crest or break. So any pictures like this that you might have seen on the internet are not real earthquake caused tsunamis. These are just usually made up pictures or from Hollywood films. So it's not actually, you don't get this big surfer kind of style wave. So I'd like you to write down that definition and then watch this video here, which is on the slide. So the link again is down below underneath the comments. Click see more if you can't see it and click that link. It's called Tsunamis 101. And if you've been following all the lessons, we've watched Volcanoes 101 and we've watched Earthquakes 101. So it's along the similar lines. It's a National Geographic video and you get a little bit more of a brief overview of what tsunamis are. So write your definition and watch that and then come back to the lesson. Okay, so where are tsunamis? Where do they happen? So probably the most common thing you'll know is that they occur on plate boundaries. But what's special about tsunamis is that they occur underwater. So they always occur in or near water of some sort. This map here is showing the biggest tsunamis in recent history. You can see there haven't been many. How many are there? 1, 2, 3, 4, 5, 6, 7 shown on that map. So that's, I think, since 1930s and 1940s, the first one. And they cause so much damage. They have been the biggest hazards in terms of numbers of deaths and economic damage to buildings, roads, infrastructure, causing injuries, homelessness. They're the biggest hazards, the most deadly hazards that we know of. They have much further reaching effects than earthquakes or volcanic eruptions, as the waves can travel thousands or hundreds of miles in many cases. So particularly, you will have probably heard of the Indian Ocean tsunami in 2004, and you've probably heard of the 2011 Japan earthquake and tsunami. These are the biggest ones in kind of very recent history that we have known. And they've travelled and affected many countries, and we're going to learn a little bit more about them today. Okay, so why do they happen? First thing I'd like you to do is watch this video to see a tsunami experiment in action. It's a BBC video and it shows a guy who's made a tsunami model after the Japan 2011 tsunami, and he shows what happens when the plates flick upwards and what happens to the water, and you can watch it happen in slow motion. So watch that, the link is down below, and then we will come back to writing an explanation as to why they happen. So on a destructive plate boundary, so remember that's when the plates are moving towards each other. So we've got one plate moving towards the other one and it pushes down or subducts underneath. And what happens is the plates get stuck and the friction, remember the friction is building up like with an earthquake when we're on land. But eventually they're going to slip past each other. And as they slip, this forces one plate upwards. And this then displaces the water above, raising in height as it reaches land. So if I draw this out for you, it might make a bit more sense. So we've got one plate here and another plate here. And remember, we are underwater. And then we've got land over here with some houses on. So what happens is these plates are moving towards one another. So this plate is moving towards this plate. And as the friction builds up here, as the plates are pushing towards each other, eventually this plate is going to slip. And what that does is push this plate upwards. And as this plate is pushed upwards, the water then gets pushed upwards as well. So we end up with a little kind of bump in the water as it gets pushed upwards. It's not usually as high as this, but I'm just drawing it quite big so that you can see it. And then as this moves towards the land, it's not that high. The water isn't forming a massive wave. It doesn't crest and break. Remember, it's not going to form waves like that because those are formed by wind and by weather. So tsunami waves, the water gets pushed upwards, and as that water gets pushed upwards, as it reaches the land here, it's going to rise up and reach and cause a problem and cause damage because it's being forced upwards. So the point of the tsunamis and how they form is actually because the plate has pushed them upwards rather than anything else acting in this area. It's a little bit like if you were to have a bucket of water and push your hand into that bucket of water quite quickly, lots of that water is going to fly out and be forced out of the bucket, causing quite a lot of mess because you have pushed and forced or displaced that water from the bucket and made it flow out of the bucket. So this is what we look like in our tsunami formation. That's just another diagram showing what it looks like. So you can see the plate pushing up, slightly clearer than mine, but the plate pushing up, which makes the water move. And what's special about tsunami waves is that the water moves in all directions. So regular waves that are formed by the wind only move in the direction of the wind, but tsunami waves move in all directions. That's why they can be so deadly, because they reach quite a lot of places. So what I'd like you to do now is complete the activity on your sheet where you number the different boxes. You number them in order so you know which one is happening first. So think about it step by step. What's the plate boundary doing? Where does the friction come from? What's happening to the plates? The forcing upwards, and then what happens to the water as that happens. So pause now and fill that in. Okay, and the kind of main independent task you're going to do today is a case study of the Indian Ocean tsunami in 2004. So there's a big earthquake here, and it's the most deadly natural hazard we've had in recent history, killing over 200,000 people. So your task is going to be to investigate the tsunami, what happened, and complete your case study sheet, which is attached to the sheet on the link that I've given you, and explain why it happened here. So what kind of were the causes in this location, bit of background information, when did it happen, how big was the earthquake, how many people were affected, that kind of thing. Then what the impacts were social and economic. Remember, social is to do with people and economic is to do with money. And then how it was managed. And you can use this link down here, which is a BBC bite-sized page, to give you lots of information, and you can use the link on the case study sheet as well. So I imagine that will take you about 15 to 20 minutes. So pause now and complete that. Okay, well done for getting to this point. You have reached the end of Hazardous Earth, all of our 5 lessons. So be sure to send me a little message so I can see that you've done it all, and let your geography teacher know that you've been working hard through this. Or if they've sent it to you, let them know that you've finished it all. And there's 3 extra tasks if you want something to do, a little bit of extra challenge. First thing is a build your own volcano model. So you can see these. You can pick which volcano you want to do, you just print it out at home, and then you stick it together. So you build, it's kind of on A4 paper, it's not too tricky to print or anything, and you cut it out and stick it together so you can make your own volcano model. I think there's 4 or 5 to choose from, which is quite fun. If you have Netflix, or if you have this DVD, you can watch The Impossible, which is all about the Indian Ocean tsunami. It is a Hollywood film, but it's based on true events, and it's quite horrible to watch, but it's quite interesting to see the impact of the tsunami. Make sure you've got your parents' permission for that, but I think it's a 12A. And the last thing you could do is, it might be fun to design an earthquake model. I've seen this one on the internet where you get Lego and Play-Doh and you move the different tectonic plates to watch how the earthquake would happen. There's lots of different examples of earthquake models you can do on that link. So click that link. I've copied it and pasted it down below so that you can do that. Thank you very much for getting to the end of this. Please like and subscribe. Like the video and subscribe to the channel. You'll get updates on all the other future videos that I'm going to release. I'm going to do a few more topics, weather and climate, and then I'm also going to do a map one as well, which you might find interesting. So a bit of revision if you've done those topics before, or something new for you as well. Thanks very much for listening.